Okay, so here we go. We have a trapezoid here on the graph, and we're going to translate it. Translate it means what? We're going to move it. So it says trace the trapezoid, but I'm not going to do that. What am I going to do? Yeah, we're going to use the units and move the points. So it says here, place your trapezoid on top, then translate it 5 units to the left and 3 units up. So this is my T, so I'm going to do 5 units to the left, 1, 2, 3, 4, 5, and then 3 units up. 1, 2, 3. That's going to be T prime, right? Then I'm going to do the same thing with R. I'm going to go 1, 2, 3, 4, 5, and then I'm going to go up 1, 2, 3. Right? Is that right? And that would be R prime. Then for P, I'm going to go over 1, 2, 3, 4, 5, and then I'm going to go up 1, 2, 3. And then over here, I'm going to do the same. Oh, that's P prime. Then I'm going to do A, which would be 1, 2, 3, 4, 5. Oh, I can't put it there. What am I doing? Then from there, I'm going to go up 3, right? So I'm going to go up 1, 2, 3. Now, I should point out now the next thing they want you to do is they want you to use a protractor. Mr. Adams is cheap. I didn't pay for the actual full-blown version of this software. So I don't have a protractor. But I can measure the angle by drawing this shape. So if I take a line here and I draw this line from here to here, what they want you to do is draw from T prime to P prime over to, that's A prime, right? Measure that angle. And so what you'll find is whatever this angle is, it should be the same for this angle. What is that measurement, you guys, real quick? I suppose I could do it on the screen. Somebody throw me a protractor. Let me grab a protractor. I'll just measure it right at it. Oh, through there. So I'll just measure. I'm going to use this protractor, and I'll just measure it on the screen. Yeah, it's going to be the same, right? So if I measure it, it's about 80 degrees, roughly. It's about 80 degrees, roughly. So it's the same. And then what I'd like for you guys to do, so then you connect all these dots here and then measure every angle. And what you'll find is that every angle is the same. Oops, if you draw it right. Man, I'm struggling, and the computer is supposed to draw the straight line, so that's where I'm at in this endeavor. Oh, when I release the pen, it always moves it. But anyways, you guys are talking when you should be working. This is a 90-degree angle. 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 And then this angle is congruent with this angle. And if you measure the length, well, you don't have to measure the length. You can count the units. From here to here is how many units? 3. From here to here, it's 3 units. If you count this one, it's 1, 2, 3, 4. From here to here, it's 4. If you count this one from here to here, it's 1, 2, 3, 4. And from here to here, it's 1, 2, 3, 4. And this one is a little more, you'd have to measure that with a ruler. It should be 5. If you measure it with a ruler, is that 5? Well, you gotta figure out how big each one of those little squares are. Anyways, does anybody have any questions? Maybe it wouldn't be 5. I gotta think that through. It wouldn't be 5. Anyways, any questions on that? So now let's go through here and finish this and answer the rest of these questions. Now, we are going to measure it. So how long is it from T to R? I know, I got to read ahead. So just erase this, erase this, erase this, erase this, erase this. All right, so how many centimeters is it from T to R? So you're measuring from here to here in your textbook. We'll measure it. It should be about 1.3 centimeters. Does that seem right? Yeah. Okay. Now measure from, so this is 1.3, and R to A, from here to here, that should be what? No, you got to use the little lines, 1.7 centimeters. Does that seem right? Well, don't guess. We're using the rulers. That's why we pass out the rulers. Use the protractors if you guys can't see it. Well, we don't have, I think some of you guys have the English rulers, so you don't have centimeters. Anyways, just write down what I write down. This should be 1.7, and TP should be 1.75. And these are all centimeters. And then if you measure the other ones, you'll see that these are the same. And as we said earlier, why do we want to check that? Well, because we're translating, which means the object is rigid. We're not changing the rotation. We're not changing the orientation. It's the same object. We're just moving it, gliding it, sliding it, whatever word helps you remember it. So you would say that it says, what do you notice about the lengths of the corresponding sides? The lengths of the corresponding sides, corresponding means that the primes are the same length as the pre-image sides, right? So in other words, TR is the same as T prime R prime. Okay, the bell's going to ring in a second, I know. And then lastly, this is 104 degrees. This should be 90 degrees. This should be 90 degrees. I'm trying to finish this before you guys leave. This should be 76 degrees if you guys measured that. And these will be the exact same. 104, 90 degrees, 90 degrees. I said it was about 80, but actually it's 76. What about the angles? They're the same. Which sides of the sides are parallel? Yep, TR and AP. Oops, that's AP. And then which sides are parallel here? Well, it's the prime. So it's TR prime and A prime, P prime. And then lastly, it says, what do you notice? The shapes are the same, it's in different spots. Yeah, they're the same, you just moved it. So in other words, the parallel lines on TR is parallel to AP, and it's the exact same thing on the image. Put all your stuff away in the things here. Sorry that we rushed through, but I just wanted to finish that problem before we left. If you have any questions, let me know.